This is a new topic as I mentioned during last session. Basically, these are the topics which doesn't have any kind of assignments as such. But these are the concepts which are used while writing any C program. So storage class was one of them, so that you can use and declare variables on the basis of your requirement, keeping in view the requirement of the problem to be solved. So that was one chapter. Second chapter was the last chapter, which was dynamic memory allocation. So again, this is the concept which is used while writing programs. In that series, because we are in the, as I told you, I have divided this full course into 4 phases. So we are into the fourth phase, last part of 4 phase as such. So preprocessor directive is one of them. Some of you might have learnt it in your college if you have already learned C language or C++ even, because preprocessor directive is exclusive part of C and C++. Java, they say that preprocessor directives are not, but after all, some file inclusion is there, file linking is there. See, when whole program is executed, it needs some help from the library, it needs help from the operating system files, it needs to communicate along with the operating system, so that everything is going to be there. But representation is different, implementation is different. That is the crux of the story. Why we learn this? Because it helps you to understand current programming languages like Python or Java or whichever out there. So understanding these concepts is very important for us. So we will start. Basically, what is important is program lifecycle. Program lifecycle many times is ignored by C programmers or any programmer, I mean, through which phases our code is passed, code goes. That is very important to know. As a programmer, we should know that. What I believe is writing code is one part of any system development or application development. So one part, maybe we can say 20 to 30% of task is writing the code, but rest 70% is design of the code, optimization of the code, flow charts, algorithm, implementation, debugging. A lot of other tasks are there which are equally important. So we are into the program life cycle. So program goes through various phases. Initially, when I give you any code, any problem rather, unfortunately, these days we have forgotten to use the pen and paper, because you have got a computer in front of you, you have got a tab in front of you, and you have got a mobile in front of you. So I think many times I think people are not using pen except signature. And after all, the technology is in at such a mode that thumb impression is actually replacing the signature. So that is I mean, I don't know, I cannot comment whether it is bad, whether it is good, but definitely when program is to be written, a problem is given for a programmer or a team of programmers. The first step is design that program and write the code, handwritten code, at least algorithm. Unfortunately, many people use that again, Microsoft Word or lot of softwares are there for design of the code. But the first step is writing the code, handwritten code. That is very important. That is the first step. I have not shown this here. First step I have not shown. The second step is writing the code. Okay. So what you can see on the left hand side on your monitor, the rectangle is there inside which E is written. So that is a source code, what we call as a source code written by the programmer, that we call using any language. Okay, in our context, it is a C language. We need a software for that. And I have discussed this issue in the first chapter. If you can recall, I told you that there is system softwares and application softwares. And I talked a lot about system software. So one of that is editor, if you can recall. Editor is a system software. So we need editor. So that's why I written E inside that uh, rectangle. That is source code. So that is the first step. Editor is a system software which is required for writing a source code. Now we save that code. What we call it is a test. Suppose test is name of our program. So that is the first step, test.c. That is rather the second step. The first step will be handwritten code, okay, which we read on the paper. Then there is a second step. Usually when we write the code, we compile it directly. We compile it. But I told you in the first chapter, there is another kind of a system software apart from the compiler, which we call it is a preprocessor. As the name signifies, preprocessor. So before processing means before compilation, obviously. So before processing, there is another software. That's why the name is given as preprocessor. So preprocessor comes into the picture. Almost all preprocessors are written in C language. Likewise, all compilers are mostly written in C language in this world. All compilers. Because C is the versatile and unique language. So likewise, all compilers are written in C language. Preprocessors are also written in C language. So preprocessor comes into the picture. Before you know that, when you compile the program, your source code is sent to the preprocessor, right? And whatever you have written in that code, that is some lot of a lot of stuff is added into that file. Lot of stuff. Unknowingly, you do not know that. It's a lot of stuff because your code, a 5 lines of code as a standalone program, it cannot execute on its own. Not possible. Not possible. It is not that much easy. So it needs help. So in that code, what code you have written, a lot of stuff is added into that code by the preprocessor. Since the stuff is added into that code, we can call it as an expanded source code, right? That is the next rectangle you can see. That's why I written P inside that. So one more system software comes into the picture, which expands your source code, and we call it as a expanded source code. Under the Linux, you can see that if you are using, if, or rather, if you have used that. But whatever stuff is added by the preprocessor, you can see that. As of now, we cannot see that because when you compile the code, your code is like that only. Only new file is created. So that expanded source code has got the same extension. On many systems, the extension is I. So test.I is created, right? Many systems. On your Windows system, this file is created, but it is internally created. It is not visible to you, right? Now this expanded source code is sent for an assembler, right? And this assembler is again a system software, and that's why I written A in the third rectangle. And the file which is created, one more file is created again at the back end. You cannot see that. That is extension is .s. So this expanded source code or assembly code, these are created at the back end. We don't have access. Okay, so on Linux system we can see that codes. This assembled code is sent to the compiler for compilation, and there we need another system software. What we have been using, what we know, and this compiler converts this code into machine code, right? Machine code. What the machine understand, the code which contains zeros and ones. That's it. So all instructions are converted into 0 1. This is a full code which cannot be read because it is a 0 1 0 1 format. So the file is created as the same file name, but the extension is .obj, which is referred to as object file. So test.obj is created, but this file is visible. At least, I mean, we cannot read that, but this file is visible. I mean, in that folder wherever you are working, that in the current directory, this file is created. It is called a obj file, right? Object code. Then before execution, because then you execute that program, right? You execute that obj file, but obj file on its own cannot be executed. Why? The reason is that you have, listen this carefully, you have called many library functions like printf, scanf, getS, right? fopen, I mean, file opening function, or a malloc, or a calloc, realloc, free. So you call many functions from your program, right? So this is a function call, if you can recall. These are just function calls. Since you have called some function, definitely you have written your user-defined functions, and you know that whenever you write any user-defined function, that function again has got its own source code, right? We have written in single file. So function call is not just sufficient, that code must be present, accessible to that program. Now, in our program, when you call many library routines like printf, scanf, malloc, calloc, free, whichever functions. Since these are just function calls, their function bodies are inside the library, right? These are inside the library. And you include that file. But when you include that file doesn't contain code of that functions. that header file contains only prototypes of that functions. Prototypes, not code of printf or code of scanf, because these are hidden by library developers, right? Because it is a proprietary, it is their knowledge, it is their copyright. So they are not going to reveal it to you. So how the code can be executed? So when you compile the program and it is converted into 1010 format, the next stage, linker comes into the picture. Linker is another system software. See how many system softwares are working together to execute your C program, and rather in sequence, right? So for a preprocessor, your source code is input. For an assembler, your expanded source code is input. For a compiler, assembly language code is input. For a linker, your .obj is input. So for a linker, your .obj is input. So what does the linker do? Linker connects all obj files. Like I have shown four small rectangles. Okay, besides the rectangle in which L is written. So L stands for linker. So this big rectangle in which L is written, that is basically a object code .obj of your source code, which is not able to execute on its own only because you have called suppose printf, scanf, malloc, calloc, free. Five functions you have called, right? Four functions suppose printf, scanf, malloc, and free. You have called four functions. Now, for these four functions, source code must be there of functions, but these are not available in .c format. These functions are provided by the library developers in .obj format. So there must be some file inside the machine printf.obj, right? Might be its name we do not know. There might be some file, separate file scanf.obj. There might be some function, there might be some file like malloc.obj. There might be some file free.obj. So all these four obj files are linked to your obj file, your obj file, that is the test.obj. Linker performs this task, and that's why it is called a linker. It links with all obj files in the library, and then what you get is the executable code. What my point? What we get is the executable code, and then that is the file which can be run, which can be executed to get the output. So there again, one more system software comes into the picture. What we call it as a loader. So loader loads this executable file into the CPU. Okay? It might be some algorithm because whole file cannot be put inside the CPU. So there must be some, no, some stack pointer might be there, right? Some pointers might be there, and one after another instruction set, because it is an instruction set of instructions are there. So line by line, all these instructions are fed into the CPU for execution, right? So this is the life cycle of whole C program. Huh? Predominant files I have written, that is the source code .c extension, expanded source code .c or .i, assembly code. Usually extension is .asm, machine code that is a .obj, and executable code that is a .exe, right? And in addition to that, there is a preprocessor. Okay, this is so these many files. Some of these are internally created, not visible. Some of these are created. So what in your folder, in your project file, usually three files are there. One is .c, another is .obj, and third is .exe. So these files are there. Two are not visible. That assembly file is not visible, and preprocess file is not visible. Right. So this is a lifetime of the C program. I hope you understood this. So as I told you before, various system softwares, editor, preprocessor, assembler, compiler, linker, and loader. These minimum six system softwares are used. I'm saying minimum. Why? Because there are other system softwares like parser is there, right? Which parses the code. Because compilation is not easy, that much easy. It has to be parsed, right? So parser is there, then lexical analyzer is there. Okay, so mm, all these are required because I don't know whether how you have, because compiler is just converts that, and if it faces problems then, but before compiler there is a parser or a lexical analyzer, how you have written the word, how you have written the keyword, and that is parsed by character, and it compares probably inside whether it follows the language rules and all these things. Okay, so that is how the whole C program is executed. You get the output. Now all this happens, behind the screens, and we are trying our own the best possible way to understand the internals of this life cycle, right? Now, our this topic is related with one of that stage, what we call is the preprocessor directives. Why it is called directives? Because directive is just what you can say like a command, like a request. Okay, to whom? Preprocessor. So, and see, don't forget that it is a preprocessor, not compiler. Many students, I mean, whichever students or a final year students or even second year students, I have conducted Viva or interview even. 99 out of 100 give me answers as, okay, this happens. File is included by whom? The compiler. Right? File is not included by the compiler. Compiler is just a language translator. It has got nothing to do along with the file inclusion. But I will tell you, 99 out of 100 will give that answer. Right? So these directives are, these commands are, these instructions are exclusively for the preprocessor. So preprocessor is, there is a C preprocessor, right? Each language has got its own processor. For in case of C++, there would be C++ preprocessor. Quite sure. Now, these are some of the topics which we are going to discuss. Macro, perhaps if you have learned C, then you might be knowing. But I am going to give you insights, more insights as far as macro is concerned. It is a macro, not micro. Okay, so when you pronounce it, when you use it as macro, not micro. Then there is a file inclusion, right? We have been including the files. So file inclusion is a part of preprocessor. It is not part of compiler. Then there is going to be a conditional compilation, right? I mean, compilation can be done with the help of condition, but without using if and else, right? So that is a condition compilation. Then how we can write multi-file project, because we have been writing a single file program, but how to divide our code into multiple files, that is very important. So I will try to exhibit it with the help of simple program. I will write simple programs so that you understand the basics, not focus. I don't want you to focus on the program logic. That is not important as far as this chapter is concerned. We want to understand how this is done. And there is one thing called pragma, not that much used. First of all, it is, I mean, machine dependent, then compiler dependent. Some pragmas may work on no 32-bit, do not work on 64-bit. So we are not going to the details of pragma, but definitely I will give you some insight about the pragma, so that somebody, suppose in the future, if somebody asks you about the pragma, then you should be able to answer those questions, because it may happen. It is a kind of a googly. Okay, whenever cricketer faces the googly, the most important part is to play that, not get out. That is important. If you cannot make a run, no problem, but at least play that, don't get out. So these are some concepts probably interviewer may try to uh, throw a googly, right? So I will talk a little bit on the pragma as well. Macro, right? So syntax, what is first of all macro? uh, it is a facility given by the Dennis Ritchie to a programmer, so that in specific uh, um, situations you can use it intelligently for various objectives, like uh, I'm going to talk on that, right? So it is a facility given by Dennis Ritchie to a programmer to implement that, right? So it is the syntax. So hash define. Now hash is intimation to the preprocessor, right? How I told you, no, what is hash? And many students say, okay, hash is intimation to the compiler. No, compiler doesn't understand what is hash. Preprocessor understands what is hash, because it is. And see, sometimes I feel there is a hashtag these days. Anywhere you go to the Twitter, you go to the Facebook, you go to the Instagram. I don't know. Uh, I'm not that much active on these social networks, but I have seen that as a matter of curiosity. I just use these apps. Uh, Rather, I am bad at handling the social network. So I don't know whether it is right or wrong, but I'm not know what you can say dexterous. I'm not expert in handling the social network. Uh, or many days I am not able to. I have got account on the Instagram. I don't know how to use that. I mean, my daughter says that just upload the photo, but I ask her, I will upload the photo. What to do along with that photo? No, somebody will see that. Okay, but somebody will see that. But what next? So these questions are there in my mind. So forgive me. The important discussion here is that whenever I see hash in Twitter or a Facebook or no everywhere hashtag, it reminds me of Dennis Rich and C language always. Why? Because perhaps Dennis Ritchie was so visionary that he was knowing 50 years back that my hash symbol is going to be used in the future. Okay, jokes apart, hash in American countries, or rather USA, Some countries they call it as a pound sign. So hash or a pound. So hash define macro is there, rather macro template is there, and there is a space, then macro substitution. So I have put it in different colors so that you understand exactly space is required. Space is required, sorry, space is required after hash define, and space is required after template, right? That's why I have colored it. So that is the syntax. Macro is usually written in caps letters. Usually. Focus the word usually. So it is not mandatory, right? Somebody will throw a googly, okay? And students do not know this. It is a convention. Macro is to be written in caps. It's never to be terminated by semicolon. Since C language programmers get used to write a semicolon at end of the statement, by mistake they put the semicolon, but that is sometimes that is sometimes it is a logical mistake, right? Then macro expansion can be expanded to multiple lines using backslash character. Usually macros are not written like this, but I told you this, you should be aware, because macros like ternary operators. Ternary operators we use very whenever that condition is very small, can be put in a single line. That's it. So it is macro is usually small and sweet, right? There is one more concept called parameterized macro. We are going to discuss this. Suppose you let multiple inputs. In a single program, I will try to cover everything. It is a meaningless program. This time I will keep the programs ready, right? So that, but there are pros and cons. If I keep the program ready, probably I can explain it in minimum time. But many times, as I go on typing, and I may tell you a lot of information that will be missing when I keep the program ready, right? When I write the program, your eyes will be rolling from the on that statement. So that is very important, right? So there will be float, circle, area, int, float, circle, circum, int, right? Four functions are there. Well, right? A single program we will use throughout our program. I want to teach a lot. This is not just related to macro. Same program I will design and develop and change and modify for teaching um, a few more concepts in this chapter. So that is the reason I am taking more time. From here also you can call get square, right? I won't do this, but just a thought crossed my mind. Let's execute this, right? Nothing in this program. We have written this kind of program. So it will take three inputs for square and cube, and three inputs for uh, circle radius, right? So enter 5, 6, and 4. Then radius, suppose 2, and 9, and 7, right? So this is how the program is executed. Nothing to talk on this. Now suppose there are only two loops here, but sometimes it may happen that number of loops are more. In the sometimes in the past we have written 4 loops in one single program. This is just example. No, don't consider this as related with the loop, but just example. Now, instead of that, if I want to execute this program for loop for 5 times, suppose I'll have to change here 5, change here 5. Okay, if any other loops are there. So instead of that, I will use the macro. So hash define, right? Suppose I write upper. You can give any name here. Okay, upper. If I write here 3, right? This is not to be terminated by semicolon. So I can give upper or a max, whatever. So I'll write here upper, right? And it gives you intelligence, right? At the same time, I can give macro for like pi 3.40, right? I'll give here pi and pi. Note that this is a capital. This is a convention, right? So if I run this code, now it has gone through the preprocessor, right? Because hash is a preprocessor directive. Similarly, this hash is also preprocessor directive, right? I'm going to talk later on this. But this hash what type now? Preprocessor command is a command to the preprocessor. So what you are telling to the preprocessor, wherever you find upper, replace upper by 3. So what does the preprocessor do? Wherever it finds upper, so where there is upper, this will be replaced by macro expansion. So this is a macro template. This is a macro expansion. Okay, it is a literal replacement. Wherever it finds upper, it will be replaced by 3. That's it. Wherever it finds pi, it will be replaced by 3.40. So it finds pi how many times? 2 times. So it will be replaced by 3.14 before this code is sent for the compilation. Is that right? See, it is not a type def. It is a macro. Type def is different thing. Type def is instruction for the compiler, and macro is instruction for the preprocessor. There is a difference. Now, suppose if I run this code, it will be executed as the earlier case. So enter number 3, 6, and 9. Radius is 4, 2, and 1. That's it, right? So it means that preprocessor has sent expanded source code to the compiler, right? Now, what if I want that program to be executed 5 times? I don't need to go at each loop. If I want to change the value of pi from 3.14 to 3.147898 like this. So only at a single location I will change that value for you, and suppose like this. Why? Because when I compile this code, preprocessor will come into the picture, and wherever it finds upper, it will be replaced by 5. Wherever it finds pi, it will be replaced by 3.144585951. Got that? As simple as it is. So I have to recompile this, and it works. It's fantastic. Got this? So this program will be executed 5 times for finding square and cube, and 5 times for the uh, area and circumference of a circle. That's it. Right? Now, this, when I say that macro is a literal replacement, it can be used for any purpose. So if I write here hash define it, uh, begin, so I can, no, I can write here begin, begin, end, begin, end, end, begin, end. It is not done like this. I want to show this that it can be written in this way. What I mean by a literal replacement. And mind you, macros has been extensively used inside the library. Extensively, right? Now this doesn't seem as a C code, but it is a C language code. So if I run this program, it will be executed. Got that? So wherever it finds begin, it will be replaced by opening curly brace. Where it finds, why actually I told you only to show you this is not programming to do. Macro is used wherever it is necessary. So this is the perfect example of macro. This is the perfect example of macro, right? So this is how, and this, in this way it is not used. Okay, this way it is not used, but I just show you to no, tell you that it is a literal replacement. Now, if I put here semicolon, okay, does the program works? It gives an error. Why? It gives an error because you are telling the preprocessor. I'm not saying compiler. I'm using the word preprocessor. So wherever it is instructing to the preprocessor that wherever you find upper, replace it by not 5 but 5 and semicolon. Why? Because it is a moron. Okay? प्रीप्रोसेसर उसका दिमाग इस्तेमाल नहीं करने वाला है, उसको जो कहा है वही करने वाला है. So it will replace wherever it finds upper by 5 and semicolon. What will happen here? It will be a 5 and semicolon. Got that? So that is the caution I'm telling you, right? As far as the macro expansion is concerned, right? Okay. Why it is written in caps letter? Very easily it is noticeable. No, you can just have a look at your program and you can immediately know where are the macros, right? That is the reason, that is the convention. You can write like this. Just suppose max, right? You can write here, right? No issues. It will work. We will not execute that so that I don't need to enter the 10 numbers again. But program is compiled. I mean, preprocessor have accepted that. What I mean, preprocessor. But the another problem is that if you look at this statement, right? If you look at this statement, you cannot know whether max is a variable or something else, right? We cannot tell whether max is a variable or a macro. That is the reason there is a convention that macro should be written in a caps letters, right? So macro versus functions. Okay. Oh, let's see use of macro, and then we will tomorrow we will see because it is almost 10 minutes past 8. Use of macro, better understanding of the program, because it is always better to read pi into r into r instead of 3.14 into r into r, because in the school days we have no by heart, we have got a formula by heart. What is area of a circle? Pi r square, right? What is the circumference of a circle? 2 pi r. So pi is there inside our mind, so it is better to write pi into r. Code is readable, right? Avoiding inadvertent changes, that is very important. If you declare a variable, to declare a variable like int max, okay, at the global level, you can change the value of max uh, from 3 to 5, 5 to 10. There is no problem. But since max is a variable, its value may be changed in the program. Okay. As far as uh, macro is concerned, macro is not a variable. Macro is not a variable. So value of macro cannot be changed throughout the code. Okay, inadvertently, by mistake. I'm saying by mistake. And efficient code and faster execution, definitely. But we will see this point tomorrow when when I discuss the difference between macro and function CC. Macro and function CC can be seen only when I discuss parameterized macro tomorrow. Okay, so we will meet tomorrow and continue our discussion. Okay.